Hello, everyone, and welcome to the Platformers live stream. We took a break for the last month, but here we are again. And today we have a really special guest because when I met Guy for the first time, I think it was 2 months ago, and I saw this presentation for the first time, and I was shocked. Like, to be honest, I wasn't aware for GraphRAGs and the impact they can create. And I think that my first meeting with Guy was super insightful for me. So, hey, Guy, how are you today?
I'm good. Thank you for having me here. Pleasure to be here and talk again about GraphRAG. Um, let's do it.
Always. I'm very excited. I'm very excited. Like, from the first time we met and say, okay, Guy, we have to take that to the community and share everything we can do about GraphRAG because not many people knows that. And I think this is what very exciting.
Yeah,
So,
I think that that's a time to kind of break a couple of stigmas or a couple of patterns that people are kind of perceive as the way to build Gen AI applications.
exactly, like MCP is maybe the newest buzzword in town, but the RAG was first,
Exactly.
and we need to make sure that, or we need to understand that it's not always overlapping, and sometimes
Mhm.
you need one or the other. So, for everyone that don't know, Guy is the CEO and co-founder of FalconDB. So, Guy, the stage is yours.
Thank you. Can you switch? Oh, thank you. Okay, wait. Okay, so thank you, Guy. Thank you for having me. As Guy mentioned, I'm the CEO and co-founder of FalconDB. I'll give you some background about GraphRAG. You probably heard about the term lately, but people are talking about GraphRAG, but I'll give you a glimpse about why you need a GraphRAG, where do you need to consider it, and why is it change, why is it different than what you're currently probably doing. So what's the problem? Let's start from the problem definition. Why do you even need to consider GraphRAG? So if you are building a GenAI application, and everyone are building GenAI application in these days, even if you're building some application based on LLM, then you probably know this kind of blueprint. You probably use this blueprint to build your application, especially if you're building a GenAI application for B2B. If your application is not a consumer application, but an application that is based on some enterprise knowledge, on some internal data that you need to use in order to be able to answer the user question, meaning knowledge that the model is not aware of, that was not trained on. It's a private information that only the organization can hold and keep. So the current blueprint or the most common blueprint to build this kind of application is commonly known as RAG, Retrieval-Augmented Generation. And what you are supposed to do, or what this pattern is usually recommend, is for you to store all the organizational knowledge in some kind of a search engine, or in many cases, a vector database that you can easily retrieve knowledge from on demand. So what usually is being done, but there are different patterns, that you take the documents, you break them into chunks, you embed them and keep them in a vector database. And then whenever someone is asking a question or trying to generate an insight based on this knowledge, then what the system is usually doing behind the scene, takes the user question, and I'm oversimplifying things here, obviously, but that's the general pattern. You take the user question, you embed it, and you go to the vector database and try to find chunks that are similar to the user question. And usually the next step will be model, this is the user question, these are the chunks that I think probably going to hold the answer to the user question. Please try to read them and generate an answer. And that's probably the most common pattern that everyone are using today in order to build a B2B mostly GenAI application. The problem with that is that it looks super nice in demos. It's working very nice in POCs and even in development. And what most organizations realize, that's really hard to put it in production if you want make sure, if you want to allow user to ask more than trivial question, if you want to allow user to generate insight, if you want to make sure that the accuracy is high enough for you to rely on mission critical application or business critical application. And what I'm presenting here is a research that Stanford published a year ago, about a year ago, something like that, comparing different legal GenAI applications. And obviously, legal is business critical. You want to make sure that your lawyer is not talking nonsense, and you want to make sure that whenever it's analyzed your legal case, it's not gonna fail standing in front of the judge. And as you probably read lately, it did happen. Lawyers did invent nonsense in court. But so they compare the different solutions, and not only on simple cases where you need to analyze a contract, but also on more complex use cases where you want to analyze big legal cases. You want to find interesting insights there. You want to work with them. And they realize that they cannot cross the 65% accuracy, which is super low in my view. And the problem is that all these different solutions are based on the same blueprint that I presented before. It's not only that. Um, you can see another paper that was published by Microsoft comparing their solution, their vector search, to other vector solution, even though they introduced hybrid search and semantic ranking and all of that. And even then, in that case, they barely crossed the 76% accuracy when they were asking more than trivial questions. And the problem is really easy to understand why or it's super easy to understand why it's not working or why it's not enough. Let's look at on a simple application that I can, let's imagine a new application, an application that is helping you ask questions about artists and their paintings and where they are published. So, for example, here I'm asking a question that might be similar to some business question or some supply chain question. Which Italian artist has the largest number of paintings on display currently in the Louvre? That sounds like a very simple question, especially if you have all the data. But if you are working with a search engine or with a vector database, then it means that you'll get a bunch of chunks out of the search engine that are similar to the other question that the model is supposed to read and understand and aggregate and maybe generate this result. So if you are doing, I don't know, top 10 or top 20, whatever, if you are trying to get the top 20 results in the search engine that are similar to the question, you're probably going to get some very good results like that, but it won't help you to answer this question in an accurate way. Even if you get 20 documents, you won't be able to accurately answer the question, who is the Italian? Because the model will only see 20 chunks and try to understand from these 20 chunks who is the most who is the Italian artist with the most painting in the Louvre. And obviously that won't be able to do it in an accurate way because it doesn't see the whole picture. So what can be done? So in order to be able to answer this kind of question, like the one I presented before, you need to see the bigger picture. You need to see the whole knowledge. You need to see all the papers that are talking about Italian artists. But obviously, you cannot load all the papers that are talking about Italian artists that are presenting something in Louvre to the model because it means that your context will blow up. It might be thousands of pictures, it might be thousands of papers, and that will be too much. So you need a way to represent this knowledge in a more structured way, and then let the model work with this structure. And it happens to be that a better way to hold knowledge, and it's not new, by the way, this model has been around for more than 40 years, is to make sure that you have a way to store the data and then traverse the hops between them or traverse the relationship and then aggregate it. And it happens to be that the way or the most efficient way to store knowledge or this kind of knowledge is using a knowledge graph. Meaning instead of just keeping all the documents in the raw data as chunks of text, you want to extract the entities and relationship from the text, build this knowledge graph, and then let the model work with the knowledge graph. So instead of just feeding the model or feeding the context with a bunch of chunks, you want to give the model the opportunity to retrieve the knowledge from the knowledge graph. In that case, in our case, I don't know, using Cypher. So you let the model do text to Cypher and retrieve the knowledge from the database. The database or the knowledge graph in that case can easily answer this kind of question if you give it the right query. So instead of you taking the user question, embed it, and try to find chunks that are similar to the question, you ask the model to generate the right query that will retrieve the right knowledge. By the way, in that case, you also gain another thing. Even if by accidentally the 4 chunks or 10 chunks can answer the question, it means that you feed them the context with 10 chunks. Here in that case, you're probably going to feed the model with 2 words, Leonardo da Vinci, and that's it. Because the database will do the hard lifting here. So that's what separates vector database or search engine from knowledge graph. Vector database is super good in semantic search. If your application is only a glorious search engine that you want to get a much more readable answer from a search engine, then vector database is probably going to be enough. But if you want to generate insights, if it's important to aggregate data from many documents or keep the relationship between the different entities, then you need to think about a different data structure, probably a knowledge graph. But let's deep dive on how it's working, how it's really working behind the scene. So I did mention before that knowledge graph is not a new concept. It's been around for many years, but it was super hard for different organizations to adopt it. In fact, very few organizations really adopt it. Probably the most known one are Google and Wikidata from Wikipedia, but most organizations did not adopt knowledge graph because it was super hard. And by the way, it's still super hard unless you have these kind of new methods to generate a knowledge graph on your own, because it means that you need to have experts in ontology and NLP and have some pipeline in order to ingest all these documents. It's happened to be that one thing that LLM are super good at is reading text, obviously, and analyzing it and extracting the essence out of them. So that's exactly how the process is being simplified using GenAI. So instead of just having experts, ontologists that will break the knowledge, then now you can use GenAI to kind of sample the data in order to generate ontology for you, or at least suggest an ontology for you. And then once you have an ontology is just a glorious name in that case for a schema, right? Once you have this schema for the graph that defines the structure of the graph, then you can use the ontology and LLM to extract all the entities from the different documents. So now instead of going through the documents, breaking them into chunks, and embed it to one of the chunks, you're going through the document, breaking it into chunks, but this time you ask the model to extract the entities and the relationship, meaning triplets. In that case, I love GraphRAG, so you have one entity I, you have the relationship called love, and GraphRAG as another entity, and you feed the knowledge graph with these triplets. So you gradually increase the size of the knowledge graph. Obviously, there are a couple more steps, like you want to make sure that you avoid duplications, but that's like a post-processing phase that you might want to do. So after you've done that, and that's kind of the parallel phase to the phase that you would have done with the vector search to generate the chunks and store them as embedding. After you generate the knowledge graph, and you can keep on feeding new documents to the knowledge graph, then in order to query it, what you need to do, and again, when someone is asking a question, instead of taking the question, embedded it, and try to find chunks that are similar to the question, now you are feeding the model with the user question and the ontology, so the model will be aware of the graph structure, and then the model will generate a query for you that will extract the relevant data from the knowledge graph. After you've done that, and that's the part on the top, you need to think about another part. There is another part of data or another chunks of data that you need to be aware of that not too many are aware of when they're defining their GenAI application these days, is that you also need to think about a more user-friendly experience or a more agent-friendly experience in a sense. It's not that you only have the organizational knowledge that you need to keep as a knowledge graph, but you also have, in case of users, the user chat history that you want to keep and maintain and make sure that whenever someone is asking a question, you also retrieve the relevant data from the user chat history in order to make sure that you have this kind of personal experience. You want to make sure that if you are building this kind of personal assistant, this personal assistant does not have amnesia, right? It's not whenever you're asking a question, it forgets everything and starts from scratch. On the other end, you want to make sure it's efficient, meaning there are two very common methods in doing that. Either you are feeding your old chat history on every question, which means that your context will blow up very quickly, not efficient, or other people are doing it by storing it again into a vector database, which means that again, They're getting glimpses of memories instead of getting a very accurate way. So you want to make sure that every user's history is being kept as a knowledge graph, as a private knowledge graph, and you need to think about it. This time, it's not the organizational knowledge. This time is a private knowledge that you need to make sure it's a privacy issue, it's a security issue, not to make sure that you are not mixing accidentally between users' knowledge graph, private knowledge graphs, or private history. So you want to keep many small graphs per user, or one graph, small graph per user or per agent, and a large graph for the whole organizational knowledge. And after you retrieve these, the organizational knowledge and the memory, then you can feed them both together into the model and tell the model, this is the question, this is the organizational knowledge that is relevant, this is the user history that is relevant, please generate an accurate response.
So one
So that,
question,
yeah, go ahead.
one question I have is like, what like I understand like the structure, the ontology, and pieces of information, but does like the GraphRAG allow me to keep the same chunks or same metadata or same any I don't know metadata about the item in the item itself in the database, or is it something that everything will be like graph mapped? Like, is there any payload to like the item on the end, or is it like everything going to be mapped into a graph?
So it's a great question. Like there are different methods in generating a knowledge graph. You can either, and there are level of solutions. What I presented is like the pure knowledge graph. You break it all into entities and relationship. You don't keep any of the raw data. There are ways that are going halfway there. When you're breaking it into a more structural knowledge graph, you're not really generating entity abstraction. You are keeping the chunks. You're generating a graph of chunks, but you are still extracting some of the topics of them or the main entities in the graph, so you can easily find chunks according to these entities. So this is kind of a mixed version. A third way is to break it completely into entities like I presented before, but also keep on each one of the entities the description or the chunks, the origin that it came from. So you can find the entities or the start the graph traversal using semantic search and then continue traversal the graph according to the relationship. So we're getting both advantage because, yeah, you're right. In some cases, the user question might not fit exactly to the entities that are in the graph, and you need some semantic search in order to start the graph traversal.
Got it, got it. It's interesting the way that you can mix or find the right solution, like in between, everything in between, and mix them. By the way, it's a good time to remind everyone that if you want to ask Guy some questions, feel free to post them on the chat. If you're watching on YouTube, just on the chat on YouTube and LinkedIn, comment on the video. We will be able to see it from here. So feel free to do that. I think Guy would love to get some question from the audience.
Sure, feel free to ask any question, and I'll try to answer them in the middle. So let's continue. So just to summarize what I presented, things that you need to consider when you are building a GraphRAG solution. First, accuracy, right? It's all about accuracy first, right? I'm not showing it here, but obviously the whole reason to use a GraphRAG is to make sure that you get an accurate response. So you need to think about, as Guy mentioned before, the strategy, your knowledge graph strategy. And there are different ways to generate the knowledge graph and a different way to retrieve knowledge. Same thing as you need to do it with vector. Also here, there are different strategies to do it. But you also need to think about the user experience. When you're switching from a vector database to a knowledge graph, if you are not considering the performance, then you might impact the user experience. So you need to make sure that you're picking a database or a graph database that can answer real-time queries, meaning you still need these couple of milliseconds response time, so you won't impact the end user experience. This also might mean that you need to make sure that the graph database can answer complex queries in low latency. But on top of that, you want to make sure that, as I mentioned before, that your solution can support multi-graphs if you want to support multi-chat history. So let's look at like different use cases, right? And what you can do with knowledge graphs. Obviously, there are the trivial demos or different trivial things that I presented before, like, I don't know, legal cases. But let's look about more interesting use cases. Um, can you switch to the other slide? To the Okay, so one interesting vertical that is starting to adopt a graph-based solution, and this is the vertical that I think is the most advanced one in adapting Gen AI, is source code analysis or source code generation, right? I guess all of you here are generating some GitHub Copilot or Cursor or Windsurf or some Kodu, or you're doing PR review. There are so many tools these days, right? Last time we counted more than 600 companies doing this kind of source code analysis. And obviously, that's super important because it can save a lot of time and help developers be much more productive. But you might already realize that when you are using a graph database, sorry, when you are using these tools on a very complex legacy project, they do not shine that much. And we are trying them all over with very complex projects, with millions of lines of code, legacy code, C code, C++ code. You might realize when you want to really fix a complex bug, even if you're giving it a lot of time and you're using, I don't know, Copilot agents or Cursor agents, you might realize the results are not that great. And in most cases, it's because it's really hard for them to grasp the whole code base. In order to serve this code base in a more efficient way, the right way or the more efficient way to do it is to use a code graph. Meaning, instead of breaking the code into chunks and storing it in a vector database and then let the agent jump around in the source code, you can serve the source code in a much more efficient way to the model and allow it to traverse the code. So for example, sorry, if you this is, by the way, an example of Click, a very common project in Python people are using. So if you ask, if the model want to try to start, I don't know, analyzing source code, maybe understand what is the name of the most common used method, then obviously we cannot answer that, as I mentioned before, with a vector because we need to aggregate something. But the graph can easily help the model generate the answer for it. So in that case, the most common method is echo. And
Guy, if you
that
can
might
zoom to the right side, that will be helpful for us to see, like, the chat itself. Oh, perfect.
Okay. So let's look at echo, for example. So echo, you see that echo is really used by called by many other methods. It's really the most used one. And that's something that you won't be able to answer by only jumping around in the code without having a bigger picture. But that's a very simple question. When you are doing some code refactoring, you might want to ask question like find me clicks, find me cluster, help me break the code and help me maybe break it into microservices, for example. All of that can be easily done on a graph and really hard to be done when you also only see glimpses of your source code. Another very interesting example, again, I'm just showing you more interesting example than just a knowledge graph.
If you can zoom in a bit, too.
I think the picture, exactly.
Perfect. Yeah.
Okay. So think about a case. I think this is a very common case that people are discussing a lot, like how do you do text-to-SQL, right? So many people are dealing with text-to-SQL and they want to do SQL on relational database. And they mostly deal with which model should I use, which model is super efficient in generating SQL. But a bigger problem is that how complex is my schema? In many cases, for example, this is a CRM example. Your schema is super complex, so complex that only to feed the schema to the model, it will be too much. We are dealing with one customer that has more than 3,000 tables in his schema. So there is no chance that the model will be aware of the whole schema and be able to generate a text-to-SQL according to the user question. So for that, what they are doing, they are generating a semantic layer using the graph. So instead of moving the data to the graph, they're keeping the data in the relational database, but they're loading the schema as a graph, and then they can ask questions like this one, like which high-value sales opportunity I have an upcoming meeting schedule and what companies are they associated with it. I don't see it here. Sorry. Oh, here you go. And what happens here behind the scene is that the model is using the user question to generate a query on this semantic layer, and then using the result from the semantic layer to generate the SQL. And you can see here the SQL that was generated, despite the fact that there are so many tables and the model just cannot see the whole schema. So these are like different solution, different places where you can use SQL. Can you switch back to the slides?
Sure. If you want, you can send me the links to that, and I will post them on the chat so people can
Sure,
try
I'll send it
them
to
on
you.
their
Yeah,
own.
sure. So a more trivial ways to use, or other places where you want to consider using a graph database or a knowledge graph, is where the data is by definition a graph. For example, when you're doing fraud detection, so you have transactions, the relationship between transactions, and you have the bank account, these are all entities that are by definition a graph already. Same thing about network analysis or security analysis or cyber security if you're building a program. Again, the data by definition is a graph. You don't even need to work too hard in order to define it as a graph. But the holy grail, I think, is working with financial data, policies analysis. These are all unstructured data that you might want to take through the process that I presented before, run through the entity extraction, generate the knowledge on the fly, and then use it to feed the knowledge to the model. And you can see different domains that are already starting to adopt GraphRAG in order to be able to generate or in order to retrieve knowledge from this originally unstructured data. Last, and I'll finish with that, who we are. So the product that we are building called FalcoDB, it's based on a product that was originally developed under the umbrella of Redis. It was originally called, by the way, Redis Graph. It's a super fast graph database. And about a year and a half ago, we took this technology and spin it out on a standalone company and realized that what you can do with the graph is kind of complete this model, this mental model of how AI should look like. If you have this Gen AI, which is your logic part, which is like the frontal lobe of your mind that know how to generate tokens and understand tokens, then you need a way to kind of mimic the way the brain is keeping memories. And knowledge graph is happen to be a very, or I don't know if it's similar way, but it's mimicking the way so you can have this kind of memory available for the brain. So that's it. Thank you. Thank you for having me.
First of all, thank you for joining. But before I'm saying thank you and thank you everyone for watching, we have a question from the audience by Chris. Chris asked, do you have some samples, graphs, or knowledge base utilizing Falcor that are on GitHub?
I think the video just freeze, but yeah,
Oh.
I just I just showed you two examples. These two examples are all on GitHub. You can take them. Like the one that the other one is not here. Can you hear me? Can you still hear me?
Yeah, we can hear you well.
Okay. Everything freeze here. Okay, now I'm back. So the other one, by the way, is called. Let me show you. The other one is Code Graph. You can see it here. It's all live.
I will show your screen.
Oh, you can share. Oh, you can share the other screen.
Cool. I'm doing so.
Okay, it's here, including this is gonna the front end that you saw before, but it's also the back end if you want to see how we are breaking the source code into a knowledge graph. How do we analyze? We have here code how to analyze both Python code and Java code. It's using tree-sitter and it uses LSP server. And then it shows you how it generates the queries based on the user question. And it also comes with some sample questions like I showed you before, but you can write your own question here or load your own. If you're running it locally, then you can also load your own GitHub and analyze it.
Wow, perfect. I think it will help many users, first of all, to understand what do they have in GitHub, which can be very, very complex. For the people that are watching us offline, after the live stream, We are going to take all of these links, put them in the description of the video, so you can always come back and try on your own. So, Guy, we will almost run out of time. And like, I think it was very insightful. Chris saying, and also I love the idea of schema as a graph for NL to SQL. Great approach, thanks. Sorry, oh, we got, okay, so we got other questions. Do Raj know we haven't covered that?
Now,
But in general, what?
by the way, Graffiti pull request is on the fly, so it should be part of Graffiti, I hope, soon. So if you
Oh,
are prefer to use Graffiti to generate your knowledge graph and to retrieve your data from using Graffiti, then you're probably going to have it soon as part of the repo.
Perfect. So, Guy, like, first of all, as I said in the beginning, it was very uh, um, like eye-opening for me to watch this session for the first time. So thank you very much for joining us. Thank you everyone in the audience for staying with us. If you do have questions, even offline, feel free to paste them and write them on the comments. We do have other live stream, like the next live stream will be in 2 weeks from now, focused on Argo CD 3.0. So, Guy, thank you very much. People at home, thank you very much, or at work. See you next time. Have a nice week.
Thank you.
Bye
Bye-bye.
bye.